Okay, so hello, I'm starting a series of videos on the Vulkan API, and I've called it like Vulkan 101, but again, I'm not a professional programmer, nor a graphics programmer, so I'm not that knowledgeable. But back in 2018, I decided I would learn Vulkan, and because at that time there were not many sources on this topic, I eventually decided I will uh, learn it and make a video tutorial on the API itself, mainly because most tutorials out there, they don't look at the API itself, but they always have try to lead you to the first triangle as quickly as possible, but I think that kind of misses the point of a tutorial on the API. So we'll be looking at my notes that I took about the API, and I will explain it to you. There is a code part that I made uh, as I was learning, but at the moment I'm only planning to make these videos where I go through the notes, and eventually I will make the code videos on the code. Um, the language I'm working is in C, but the point is again to understand the Vulkan, and I think if once you understand the API, the language you use really doesn't matter. Okay, so for this initial video, I wanted to just go over some basic stuff, and uh, so once we go to the API notes, well, what we see wouldn't be a complete mystery, and we'll be able to identify most of the elements or what's going on. So again, uh, the first part I want to touch on is bit masks. And bit masks, because I wanted to this series to be mainly oriented to people who probably are coming from a higher level language, or probably are just starting their programming journey. So I will explain quickly these very simple concepts that I think probably are explained in every computer science program. So basically, a bit mask is a very simple concept. It looks at hold on. It looks at integers, let's say 2, as a series of ones and zeros, which they are to the computer, but basically takes, let's say you have 4 bits, and like 2 is 0010, and it doesn't look at it as a number 2, but it looks at as a 4 boolean values. Basically, since one can be either one of these can be 1 or 0, and that's the basic of it, because it it's a clever way to pack booleans into a single byte, because like, let's say 1 byte, as you all know, is like 8 bits, which is like 8 I think there are 8 basically 8 possible boolean values. And when we're dealing with Vulkan will treat things we want to enable, or things that are enabled in the hardware, as bit mask, which basically, yeah, boolean values packed into some kind of an integer. I think most of them are like 32 integers. Basically, you have 32 possible ones and zeros. Get away. Okay. So the basic of bit masks is bit mask operations, bitwise operations, and in Vulkan we'll be using for finding these features or enabling, we'll be using the and the or. And as I marked in this here, that's how I have it in understand in my head, that and is a mask. Basically, if we want to find out if a bit is turned on or off, we used and here's the simple explanation. I think this was 11, 8, this is 6. These are integers. Again, if you somehow try to debug these bit masks or flags, as Vulkan will give it to you, you have to uh, have some kind of function that transforms them into bits, or it'll you will just have like integers printed to you to the terminal. But again, you can check and for its truth table, as it is called, and it's very simple. If it means you only get one when you have like ones in both of these values, both of these integers, and in the bit position, like this is like say 0, 1, 2, whatever. And if like this bit position have both of them have in both integers you have 1, it will return 1, which means that you can do like this. This will be a mask, and if this was 1, it will be 1 here, but in this case it's not. And the other operation you can do is or just this operation or just says if either of these is 1, it will be 1 in the result. And this is why I call it add, because this is how I envision it. Is basically I add this to this and the result is like this. I think this is should be 1. Anyway, my mistake. Clean this up. Come on, clean. So the one way we use these operations is for checking for flags. Again, flags are used by Vulkan when we want to check for them. Is basically Vulkan is giving us some kind of information and we have to check what the information is. Here I wrote we check for flags by using the AND bitwise operation. Thus the values we use are used as masks, basically, because Vulkan we have in the headers, Vulkan headers, we'll have like flags and we will use them as, okay, mask this value that Vulkan returned to us to see if it matches. If it produces 1 or a value that is greater than, I mean, it produces a result that is either 0, which means it's disabled, or the value is greater than 0, which means the feature is enabled. And here I did a simple example where Vulkan returns this flag value, which is like yeah, it's 4, and we're checking our VK flag, and these are the bits, and the bits match because it's and these ones and ones that will result in, again, basically this same number, and the check will say, okay, is whatever number we have as a result, is that greater than 0, and it will mean, and this check will result in true, and it will mean that our feature is enabled or is available. And in the case where we're checking for a flag that it's not like it's not enabled in the value Vulkan gave us, it means it's false and therefore it's disabled or unavailable. Here I wrote quickly like to remind you and myself that flags use the bits of the integer, therefore flags are always a power of 2, basically 1, 2, 4, 8, with because they represent Boolean values, so they cannot be 1, 1, which is 3. So this is mainly if you look at the documentation and if a value is not explicitly marked as flag, but I think all of them are. But even if you miss the name, you just look at the values, and if it's like on a power of 2, it's a flag, so checking for it, you have to do the end. Next is checking for enums, and basically both the flags and the enums are enums. If that makes some sense. And an enum is basically a type of variable declared in C, which is like enum some name and curly brackets, let's say here, and we declare like A, B, C, D. And one way to look at it is basically having an alias for the integers, like 1, 2, 3, 4. That's how I see it. Basically, these aliases for integers, and if you check the flags Vulkan gives us, or the in the header, the Vulkan header, you will just get integers. But their point is to be treated as bits. However, when we are dealing with some enums, and that's again the way to tell between the two use cases is, again, the flags always on the power of 2, while what I call the enums are just values as integers. So again, we're checking for enums in the same as the flags with AND, but instead of only checking if the value is true, basically if the value is just bigger than 0, yeah, it's true if it's bigger than 0, or false if it's 0. We check for the actual value of the enum, or yeah. So again, the same case where the value is 4, and if our enum is 4, it will be true. But if enum is like 6, it will result in false. And this is how we should check these values, because yeah, it will get like bad results. And at the end, how do we enable flags? We use the OR again. As I said, I think of an OR as an add. Basically, we are adding bits. And this is like an example. It's a flag value. It's some kind of a variable we'll pass to Vulkan, and we want to enable some feature, and we say OR this flag, and it will result in the same, because this was 0. But when we want to add another flag, it will give us this value, and Vulkan will just look at, again, like our masking, like we were doing with the mask. It will mask each bit, and it will check if that bit is enabled or not. Next, we have like quick overview, because I found it really easy to if I want to use let's say a functional struct or an enum, and I just quickly am able to, even if I don't know the name, I just quickly identify it by using this logic that they had in the API. Basically, small lowercase vk, whatever the name is, functions. So you can type vk small, and if you want a function, and usually LSPs will give you quickly all the possible functions. If you can't remember them from the top of your head, you can't remember. If you need structs are capital V, small or K. Enums are all capital VK underscore, and everything after it, like all the description what this flag or an enum is all in capital letters. Next, we look at the function types. There are basically these few types